is a question which is there in GATE 2010, which is a 1 mark question, and this is the question number 21 of GATE 2010. So which states that a system of n non-interacting classical particles, which are point particles, is constrained to move on the two-dimensional surface of a sphere. The internal energy of the system is, and there are 4 options which are given. So this is a 1 mark question. 2 things which are important which we can deduce from this particular question. So what are the things which are given? We will first note it down, and after that we will solve the entire question. So again, a system of n non-interacting classical point particles. So given that there are n non-interacting classical point particles and which is constrained to move in the two-dimensional surface of the sphere, what we need to find is the internal energy of the system. So let's see the solution of this particular problem. Yeah, so this is the same question, the question number 21. So what are the given conditions? We have first noted it down. So given things are that there are n non-interacting classical point particles. So this n non-interacting classical point particles is one of the assumptions of the kinetic theory of gases. So this non-interacting classical point particles is one of the assumptions of the kinetic theory of gases. So we will be using this particular theory to understand this particular question and proceed further. Second thing which is given here is that the particles are constrained to move on a 2D or the two-dimensional surface of a sphere. This is the second thing which we can deduce from this particular question, which is given. So from this second point, from these two, we can deduce that the degrees of freedom. Now what is the degree of freedom? It is defined here. The degree of freedom is the number of independent coordinates required to define the position of the particle accurately or completely. So as per the given information, that is, particles are constrained to move on 2D surface of the sphere. From there we can deduce that the degree of freedom is 2. So for each point particle, the degree of freedom is 2. This is what we can deduce from the question. Now how to proceed? How to find out the internal energy of the system? Because as we can see that it has been asked to find out. So to find the internal energy of the system. Internal energy of system. This is the thing which we need to find. For that, what we will use is the law of equipartition of energy. Now what does this law of equipartition of energy states? So there are 2 points in this particular law which I have stated here. One is, for a system in equilibrium at temperature T, the total energy of the system is equally partitioned. It is equally partitioned among several degrees of freedom. And the second point is that energy associated with each degrees of freedom is half kBT. So half kBT is the amount of energy which is partitioned in each degrees of freedom, where kB is the Boltzmann constant and T is the equilibrium temperature which I have defined here. Therefore, for one particle, what will happen? The amount of internal energy will be U is equal to, actual definition is F into half kBT, because for each degree of freedom, half kBT of energy is partitioned. Therefore, here in this case, what we have deduced from the question, that since the particle is constrained to move on a two-dimensional sphere, which is given condition, particles are constrained to move on the two-dimensional sphere, two-dimensional surface of the sphere. So the degree of freedom is 2. Therefore, for one particle, the internal energy will be 2 into half kBT. Therefore, for one particle, the amount of internal energy because of the movement of that one particle is kB into T. Right? Now, for n particles, then the internal energy becomes n into kB into T. Therefore, n kBT is therefore the internal energy of the system. So this is the answer to the first question, and the answer is correct option is C. As we can see from this particular question, that C is the correct option, whose value is n kBt. Therefore, this is the correct option. So this is the particular solution and the step-by-step solution of this particular problem.